Hello viewers, welcome to my channel. I'm Hasham Ali Khan. So now I'm going to start the new topic, t-test. Last 5 videos I have prepared on the problems on Z test. So if you have not watched those problems, you cannot be able to understand this. Because the t-test problems are very similar to Z test. So when we have to apply Z test and t-test, it depends on the sample size. For large samples, we apply Z-test. For small samples, we apply t-test. So when a sample can be called a large sample, if the sample size is 30 or more, it is called a large sample, we apply Z-test. If the sample size is below 30, it is called small sample, and there we apply t-test. The problems are very much similar. In Z-test, the problems are concerned regarding comparison of population mean and sample mean, and comparison of two sample means, or proportion, sample proportion with population proportion, or two sample proportion. All these type of problems we have already done in the last 5 videos. And the 5 steps we have applied. The first step, laying down of hypothesis, null hypothesis, alternative hypothesis. Null hypothesis, no significant difference between population and sample. Then alternative hypothesis, yes, there is difference. The sample mean and population mean are significantly different. That's what we have to frame in hypothesis, first step. Second step, level of significance. Normally level of significance will be given in the problem. If it is not given, we assume. Normally we assume at 5%, 0.05. Then we apply the third step, that is test statistic. In this test statistic, we apply the formula of Z. The different formulas are there depending on the contents of the problem. So we apply the formula and compute and find out the computed value of Z. This is the third step. Fourth step, critical region. We consult the table, area table. In that area table, we find out what is the critical value of Z. The third step, we have computed value. Fourth step, we have critical value. Now compare this computed value of Z and critical value of Z and give the decision whether null hypothesis is accepted or rejected. These are the 5 steps we have already applied in Z test. Same number of steps we have to apply in t-test also. One more extra step will be there. There we have 5 steps. Here we will have 6 steps. But the procedure is absolutely same. And only the formula will change. So my suggestion, if you have not watched those videos, go to the playlist of my channel. Select the subject statistics for management. Select the videos sampling theory. Then watch the videos of Z test. Be acquainted with the procedure of hypothesis testing. Then you can be able to understand. Now I am going to start the problems on t-test, small sample test. So before starting the problem, I expect my viewers to have a printout of the problems, which I have given in the link under my description. So take a printout and keep it ready. Apart from this, I have already uploaded the table, t table. That means the table value of t distribution. It is also uploaded in the description. So take a printout of this t values, table values of t, and also the problems on t distribution, and keep it ready. Now before starting, take a screenshot of the solution of the first 2 problems, then I'll explain. Come on, see the very first problem on t-test. In the past, a machine has produced washers having a mean thickness of 0.05 inches. A company which produces washers. So, a machine has produced washers whose mean thickness, that means the population mean, is 0.05 inches. To To determine whether the machine is in proper order, that means the washers are produced by the machine. The machine settings are there. The machine settings are such that every washer should have a mean thickness of 0.05 inches. That is the population mean. To determine whether the machine is in proper order, a sample of 10 washer is taken, of which mean thickness is 0.053 inches and standard deviation is 0.003. Test the hypothesis that the machine is working in proper order. So before starting, first you should understand the problem. Understanding the problem is half solved. So give more concentration. In a company, washers are produced by the machine. The machine was set in such a way that the mean thickness of every washer should be 0.05 inches. Now the company wants to find out whether the settings are correct or not, whether the machine is working in proper order or not. To check that, a sample is taken. The sample is 10 washers. So sample size is 10. So here makes the point clear. It's a small sample because less than 30. Less than 30 sample size is a small sample, and for small sample we apply t-test. So 10 washers are taken. For this 10 washers, the mean thickness was 0.053. This is the mean of the sample, and sample standard deviation is 0.003. Standard deviation of sample is given. Now we want to test whether the machine is properly working or not. Actually, the thickness should be 0.05, but the sample mean is showing 0.053. So apparently it looks like the population mean and sample mean are different. But after testing, we can be able to conclude whether the difference is significant difference or insignificant difference. If the difference is insignificant, then the machine is working properly, correctly. If the difference is significant difference, then we can say the machine is not working properly. The machine setting are out. So test, we have to make the test. Now we are given n is equal to sample size 10. X bar is equal to sample mean 0.053. Small s is the sample standard deviation. I already told you parameter and statistic. Parameter is the statistical measure of population, and sample statistic is the measure of samples. So measure of population are called parameter, measure of samples are called statistic. So you have to remember the notations. X bar is the sample mean and mu is the population mean. Sigma is the population standard deviation. Small s is the sample standard deviation. So small s sample standard deviation is 0.003 and population mean mu is equal to 0.05. This is the complete information given. Now we apply the steps. The first step is null hypothesis, HO. As usual, what we have done in z-test. So here null means no difference. There is no difference between population mean and sample mean. The population mean is 0.05. So we assume there is no difference, mu is equal to 0.05. There is no significant difference between population mean and sample mean. The machine is working in proper order. That is the null hypothesis. Same type we have done in z-test also. Now alternative hypothesis. H1. It is denoted by H1. Mu not equal to 0.05. It is opposite. In alternative hypothesis, we will take the opposite. Here, no significant difference. Here, we will take significant difference. Mu not equal to 0.05. When it is not equal to, it is a two-tailed test. Two-tailed test. Rejection region will lie on both the sides. There is significant difference between population mean and sample mean. The machine is not working in proper order. Null hypothesis, the machine is working in proper order. Alternative, the machine is not working proper order. The mu is not equal to 0.05. This is the first step. Second step, level of significance. It is not given in the problem, so we assumed as 0.05. Assumed. Degree of freedom. This is the new step required in t-test. This degree of freedom step was not there in z-test. So in z-test only 5 steps. In t-test we have 6 steps, 1 extra step, that is degree of freedom, DOF. The formula is V is equal to n minus 1. V is equal to degree of freedom. N is equal to sample size. What is the sample size here? 10. So 10 minus 1, it comes to 9. V is equal to 9. V stands for degree of freedom. So degree of freedom is 9. How many steps are over? 1, 2, 3. 3 steps are over. Now fourth step is test statistic. Here we have to apply the formula to find the computed value of t in this test statistic. Since the sample size is small, under HO, the test statistic is the formula t is equal to x bar minus mu divided by capital S by under root n. The formula capital S. So first we should know what is capital S. It is the unbiased estimate of population standard deviation. The population standard deviation will be denoted by sigma. But in our problem, sigma is not given. Sigma is not given. So we have to compute capital S. Unbiased estimate of population standard deviation. So what is the formula for capital S? N divided by n minus 1 into S square, small s. This is small s, this is capital S. Small s means sample standard deviation. Whereas capital S means the unbiased estimate of population standard deviation. But that's what we are finding out. So n divided by n minus 1 into s square. N is 10. So 10 divided by 10 minus 1 into s. S is 0.003. 0.003 square. So first what we'll do, 10 divided by 10 minus 1 is 9. 0.003 square, it comes to 0.000009. Right? Now multiply this factor into 10 divided by 9. You'll get 0.00001 under root. So after root s is equal to 0.0032. Remember, only listening and watching the video is not enough. If you want the complete practice, take a calculator, simultaneously make the calculations and be perfect. Be sure that you are getting the same answer. Right? Practice is compulsory for statistics. Only watching the video is not enough. So capital S is equal to 0.0032. Now we apply the formula T. T is equal to X bar. X bar is how much? 0.053 minus mu. Mu is how much? 0.05 divided by capital S. Just now we got 0.0032 divided by under root n. N is 10. So 0.053 minus 0.05, 0.003. So 0.0032 divided by under root 10, you will get 3.162. So 0.003 divided by, divide this 0.0032 divided by 3.162, 0.001012. Now divide it, you will get t value 2.96. So finally we got the computed value of t, 2.96. That's all. Step number 4 over. First step, hypothesis, laying down of hypothesis, null and alternative. Second step, level of significance. Third step, degree of freedom. Fourth step, test statistic, remember the formula. That's it. Now fifth step is critical region. Now we have to consult the table. The table value of t at 5% level for significance level at 9%, 9 degree of freedom for 210 test. Now critical region will depend on 3 things. First of all, level of significance. What is the level of significance here? 5%. Secondly, degree of freedom. What is the degree of freedom? 9 degree of freedom. Third, whether it is a 2-tail or 1-tail, it's a 2-tail test. So this critical region depends on 3 things. 2-tail test, 5% level of significance and 9 degree of freedom. So here, the table value of t at 5% level of significance at 9 degree of freedom for 2-tail test is plus or minus. When we will take plus or minus? When there is a 2-tail test. Because the rejection region will lie on left side as well as on right side. Left side minus, right side plus. So plus or minus 2.26. Thus the critical region lies for t less than equal to minus 2.26 and t greater than equal to plus 2.26. तो minus 2.26 से नीचे या plus 2.26 से ऊपर, that value will go to critical region, right? Now how do we get this 2.26? Now you have to refer the table. I already told you this table I have given in the link under my description. Take a printout. Otherwise, you can refer to any textbook of statistics. You will find t values, table values of t, or in Google also you can find. Right? So here in this table, left side you can see a DF. DF stands for degree of freedom. So here 1, 2, 3, 4 like that up to 30 is given. Our degree of freedom is here 9. Degree of freedom is 9. So in the row of 9 you see. And column it is given probability 0.5, 0.1, 0.05, 0.02, 0.01, 0.001. These are the different probabilities, percentages. Ours are 5%. 5% means 0.05. So in the column 0.05. In the column 0.05 against the row 9, because degree of freedom is 9, level of significance is 0.05. 0.05. So you can see 9 degree of freedom 0.05, it is 2.26. It is 2.26. So that 2.26 I have taken here. Now I have two values. Computed value of t 2.96. Critical value of t 2.26. Now decision. Compare. The computed value of t 2.96 is greater than the critical value 2.26. So it falls in rejection region. It falls in rejection region. Example I'll show you here. See here. This is the curve. This is the normal curve. Now rejection region will lie on both the sides because it is a two-tailed test. This is left side minus 2.26. This is right side plus 2.26. This is the rejection region. This is also the rejection region. And in between we have acceptance region. Right? So from this diagram you can see any value below minus 2.26 reject. Any value above plus 2.26 reject. So our computed value is 2.96. Where is that? Here. So 2.96 will come here. So which region? Rejection region. So what we are rejecting? The null hypothesis we are rejecting. This null hypothesis I am rejecting. When null is rejected, which is accepted? Alternative is accepted. So what the alternative says? The machine is not working in proper order. There is significant difference between population mean and sample. This is accepted. Here conclusion. The computed value of t 2.96 is greater than the critical value of t 2.26. So it falls in rejection region. We reject the null hypothesis and conclude there is significant difference between sample mean and population mean. The machine is not working in proper order. That's it. So I have explained each and every point of this t-test. First problem on t-test. We have compared the population mean with sample mean. That's it. Now, second problem. A test of the breaking strength of 6 ropes manufactured by a company showed a mean breaking strength of 7,750 kg and standard deviation of 145 kg, where the manufacturer's claim is that the mean breaking strength is 8,000 kg. Will you support manufacturer's claim? A rope manufacturing company, the cable rope. So company which manufactures cable rope is claiming that the breaking strength of that rope is 8,000 kg. That means up to 8,000 kg it can lift. Breaking strength 8,000 kg. That is the contention of the company, claim of the company. Now we want to check whether company is saying correct or not. We want to confirm. So we have taken a sample of 6 ropes. It's a small sample. less than 30. So 6 ropes we have taken and we calculated the breaking strength. The breaking strength of 6 ropes comes to 7,750. It is less than 8,000. Company is claiming 8,000, but our sample is showing only 7,750 with a standard deviation of 145 kilogram. Now we want to confirm whether company's contention is true or not. Company is claiming 8,000. 8,000 is correct or not? Again t-test, because it's a small sample. So here, n is equal to 6, sample size, 6 ropes, x bar, sample mean. The sample mean is 7,750 kilogram. And s, small s, is the sample standard deviation, 145 kilogram. Mu, population mean. The company claims 8,000 kilogram. That's it. This is the information given. Now we put the null hypothesis. Null hypothesis HO. Mu is equal to 8,000. No significant difference between population mean and sample mean. Whatever the company claims, that is correct. That means 8,000 kilogram company claims, 8,000 is correct. So mu is equal to 8,000. No significant difference between population mean and sample mean. The manufacturer's claim is true. Alternative hypothesis. Mu less than 8,000 kilogram. See here we have taken not equal to, two-tail test. Here I am taking less than 8,000. Why? Student will get confused. In one problem I am taking two-tail, here I am taking one-tail. The reason is, here the problem says we have to check whether the machine is working in proper order or not. That's it. So yes or no. So we have taken not equal to, right? But here the company wants to, the company is claiming that 8,000 kilogram is the breaking strength, but our sample is showing 7,750. It is less than 8,000. So first null hypothesis, we accept the company's claim. We accept the company's claim that 8,000 kilogram is the breaking strength. Alternative hypothesis, no, the company's contention is not true. The company's claim is not true. It is less than 8,000 because our sample is showing less. Sample is showing less. So mu less than 8,000, left tail test. When it is less than, it is left tail. If it is greater than, it will be right tail. So it is one tail test. Now there is significant difference between population mean and sample mean. The manufacturer's claim is not correct. Null hypothesis, manufacturer's claim is correct. Alternative hypothesis, it is not correct. Now any one of these hypotheses we have to finally select in decision. If null is selected, alternative will be rejected. If null is rejected, alternative will be selected. That we can come to conclusion in the last step. Level of significance, nothing is given in the problem, so I assumed at 0.05%. The degree of freedom, the formula for degree of freedom, V is equal to n minus 1. N stands for sample size. What is the sample size here? 6. So 6 minus 1, 5. The degree of freedom, 5. Test statistic, same formula what we have applied in the first problem. Since the sample is small, under HO the test statistic T is equal to x bar minus mu by S by under root n. Capital S by root n. Capital S is the unbiased estimate of population standard deviation. An estimated population standard deviation. So what is the formula for capital S? N by n minus 1 into S square. Already we have applied here also. N by n minus 1 into S square. Small s. Small s means sample standard deviation. So here n by n minus 1. 6. 6 by 6 minus 1 into 145 square. Small s is 145. So 145 square. Now you subtract. If you square 145 square into 6 divided by 5 under root, you will get 158.84. Final value. And not making all calculations, you have to do the calculation yourself. I am explaining you how to do. 145 square, 145 into 145. Then into 6 divided by 5. Whatever value you get, put under root. You will get 158.84. That is S. Now we find out T. T is equal to x bar minus mu. X bar is how much here? 7,750. Mu is 8,000. So 7,750 minus 8,000 divided by S. S is 158.84. Divided by root n. Root n is root 6. So 7,750 minus 8,000 minus 250. Numerator we are getting minus 250 divided by 158.84 divided by root 6. Root 6 is 2.45. So minus 250 divided by, if you divide this, you will get 64.83. So minus 3.86. This is the computed value of T. Now, critical region. Now here there is one difference. The table value of T at 5% level for V is equal to 5 for left tail test is minus 2.02. Left tail, that's why I am taking minus. If it is a right tail, it will be plus. If it is two tail, it will be plus and minus. Previous problem we were having two tail test. That's why I have taken plus or minus. Where is it? Here. But now it is left tail test, so I am taking minus. So minus 2.02. One column before 0.05. So T is equal to minus 2.02. There is a difference here. If it is a two-tailed test, take the concerned column. If 5% is there, under 0.05 column. If 5% is there, under 0.05. But if it is one-tail test, one column before you take. So here, what is the degree of freedom here? Degree of freedom is 5. So row 5. In the row 5, column 5%. In 5% we are getting 2.57. But don't take 2.57. The 2.57 we will take only if it is a two-tail test. But here it is one-tail test. So one column before you can find 2.02. 2.02. So remember, if it is a two-tail test, same column. 5% means 0.05, same column. If it is a one-tail test, whether it is left tail or right tail, so one column before you should take. So row 5 degree of freedom. Column 0.05, it is 2.57. Don't take 2.57. Before that, you will get 2.02. Take 2.02 for one tail test. So minus 2.02. This is the critical value of T. Now decision. Now compare it. Now I am comparing this critical value with the table value. See here, with the help of diagram I am showing now. This is the normal curve, right? Now the critical region will lie on left side. T is equal to minus 2.02. This is the rejection region. And this is the acceptance region. Rejection region is only on the left side, left tail test. Right side we don't have any rejection, all acceptance. So this T is minus 2.02. Now computed value of T. What is the computed value of T here? Minus 3.86. So minus 3.86 is less than minus 2.02. Again I repeat, minus 3.86 is less than minus 2.02. So it falls in rejection region. Here it will fall. Minus 3.86. So minus 3.86 is less than minus 2.02. So it falls in rejection region. So we reject the null hypothesis. We reject the null hypothesis. What the null hypothesis is said? The null hypothesis is no significant difference between population mean sample mean. The manufacturer claim is true. This we are rejecting. The manufacturer is wrong. The breaking strength is less than 8,000. The breaking strength is less than 8,000. So conclusion, the computed value of T minus 3.86 is less than the critical value minus 2.02. So it falls in rejection region. Null hypothesis is rejected. We conclude that the company's claim is false, not true. The average breaking strength of cable is